Okay, class, let's wait for 2 minutes and we'll start with the class. All right, class, we had started with uniformly accelerated motions and three equations we had seen. V is equal to U plus AT, S is equal to UT plus half AT square, and V square minus U square is equal to 2AS. So these were the equations of motions which we had seen. Now, all the quantities I have discussed with you and two questions I have discussed. One which was exact copy of the first question, right? These 12. Two more numericals we'll practice. This question first, write down this question, at least write it down, so then I'll scroll it up and then I'll explain you. Two questions, then we'll move on to the next topic, which is motion under gravity. First, write down this question quickly. Okay, Abir has done. All right. Now see, this question says that a motor car starts from rest. So we'll make the exact case of what happens. So it starts from rest. Let's say this point is A and it is starting from rest and it accelerates to a point. Let's say this is B for 10 seconds. So we know that the first time that is given T1, this is given as 10 seconds. To a velocity of 20 meter per second. Here the velocity is 20 meter per second. This is the first case. Then next, what does it say? It says that it then runs at a constant speed. So it is running at a constant speed. Let's say, so if it is running at a constant speed, now the speed will also remain 20 meter per second, right? And is finally brought to rest. Now from here, this is brought to rest in 40 meters. Means here the distance S3, here the distance, this is 40 meters. Total distance which is covered is 640 meters. Total distance which is covered, this is 640 meters. Acceleration, retardation, total time taken. Basically, you have to find out all the things which are missing. You don't know the acceleration here. You don't know the distance here. You don't know the acceleration here, the distance here, the time here. You do not know the final velocity here. No, final velocity we know. Brought to rest. So one more thing, class. The final velocity. This will be 0. This will be equal to 0. Because ultimately the car has been brought to rest. So this will be 0. And what all things we do not know here? We do not know what is T3. We do not know what is A3. Like this, all the things which are missing, we'll be calculating. Now we'll go part-wise. Let us solve first A to B. Solve this from A to B part. What all things are given? U is given as 0. Initial velocity. Final velocity for this duration, A to B. A to B, just this duration, the velocity is 20 meter per second. And the time is 10 seconds. So velocity is 20 meter per second. Time is 10 seconds. And these are the first case. First case is velocities. So we'll use the first equation only. V is equal to U plus AT. So V1, U1, A1, T. So V1, this is 20 is equal to 0 plus A1 into T is 10. 10 A1 is equal to 20. Acceleration 1 is equal to 2 meter per second square. One thing now we do. Let us add in our diagrams. This is now 2 meter per second square. Then we say S1. See, everything we have, let us calculate distance using S is equal to UT plus half AT square. So S is equal to UT plus half AT square. Now what we'll do? We'll write 2 for all the things. 2, 2, 2, 2, 2. Let us put the values. S2 we have to calculate. Initial velocity into time, this is 0 plus half. Acceleration is also 2 and time is 10 seconds. So 10 into 10 is 100. So distance first is 100 meters. Clear? So A to B part is solved. A1 is 2 meter per second we have concluded and distance is 100 meters. Now class, tell me, let's come to the second part, but before that one thing. S2 is very clear and obvious. This is 100, this is 40. And total is 640. It means just this part is missing. Only this portion is left. 140 is being taken from 600. So how much will we be left with?
500.
500. Very good, Abhi. So this is distance is here. Distance here is 500. We'll be left with just 500. Now add 100 plus 500 plus 40 gives you 640. So so distance is very clear over here. Now class, acceleration is also very clear over here if you pay attention. Acceleration is also very clear over here. If velocity initially and the final velocity between this duration B to C is still the same, it is 20 meters per second. Can anyone tell me what should be the acceleration? Velocity is constant. Value of acceleration should be C. Acceleration is rate of change of velocity. Whenever there is a change in velocity, acceleration is produced. So if there is no change in the velocity, then there is no production of acceleration. Simply this acceleration is zero. Other students also have to open their cameras. It's not just for Alina. So when we are talking about the second part, that is B to C, acceleration would be zero because the speed is constant. Actually, the velocity is constant, not the speed. All right, it is constant. One more thing we'll do. Time we can calculate. Velocity is 20 meters per second. And distance we have calculated, which Abhi has answered, it is 500 meters. So time is equal to distance upon speed. 500 by 20, this becomes 25. So time is equal to, this is T2, 25 seconds. So look here, all the things that were missing, we have calculated. Acceleration 0, distance 500 meters, time is 25 seconds. Now comes the last part. We know the distance, we know the initial velocity, we know the final velocity. What is retardation? Retardation basically means negative acceleration. If the velocity increases, we get positive acceleration. If the velocity decreases, we get negative acceleration. And this negative acceleration is called as the retardation. Now, look, what is the time? Time also we have to calculate. Let us calculate the time also. So this is from C to D. So V final is 0. That is the V. Initial velocity is 20 meters per second. So this is U, our initial velocity. S3 is equal to 40 meters. Acceleration 3 we have to calculate. One thing class, before we calculate, okay, let us use the third equation of motion to get the acceleration. V square minus U square is equal to 2AS. This is V3, U3, A3, S3. What is V3? Means the final velocity, it is 0 square. Initial velocity for this part, it is 20 square. 2 into acceleration, we have to calculate, distance is 40. This is minus 400 is equal to 80, A3. Look class, automatically you are getting minus 5 meters per second square, which is the negative acceleration. And this negative acceleration is only known as retardation. This is known as retardation. So we can use and put the value as minus 5 meters per second square. That's the value, minus 5 meters per second square. Just one thing is left. And what is this retardation? Retardation is when the velocity decreases. Velocity decreases and you get your acceleration always is negative. For the time, what you can do, V is equal to U plus AT, you can use. What is V? 0. Initial 20 minus 5T, T3. So 5T3 is equal to 20. So T3 is equal to 4 seconds. One more thing we had to calculate, that was the total time. So see, total time will be 25 seconds. First we had 10 seconds, then 25 seconds, and now these 4 seconds. So 35 plus 4, 39 seconds. So this is the total time, t. This is the acceleration. All the other were the acceleration, and this is the retardation. Write it down, class. Any doubts? Let me know. Done?
Yes.
See, there is one more equation. See, three equations we have already studied. Now, one more equation is present, which we have to study. Now, these were the three uniformly accelerated equation motions. There is one more equation for a particular nth second that is known as displacement covered in nth seconds. Now, look at these two cases which are written on the screen. This says that this is the S1 distance in the first second. This is the S2 distance, and this is the second second. This is S3, this is the third second. This is S4, which is the fourth second, right? And one is that which we have been studying. This is 0 to 3 seconds, 0 to 2 seconds, 0 to 3 seconds, like that. So there's a difference between 2 seconds and second, or there's a difference between 3 seconds and third second. If you are asked to calculate these, the first second, the second second, see, when we say 2 seconds, calculate the distance in 2 seconds, it always means we are calculating from the starting 0 to 2 seconds. But when it says second second, or third second, or fourth second, means just this fourth, and whatever happening is happening in this fourth. So this is the difference. So be careful. If a question is in terms of that, then there is one equation which you have to use. Sn means distance covered in nth second is equal to u plus half a to n minus 1. This is the equation which you have to use. What is Sn? Sn is the displacement covered in the nth second. This is the displacement covered in nth second. What is u? It's the initial velocity. What is a? A is the acceleration. N is the nth second. Right? Let me solve this question, then you can write it all together. This is that a car starts from rest and accelerates. I'll be just doing the second and the third part. See, second part says distance covered in 3 seconds. So body starting from rest means u will 0 and acceleration is given as 2 meters per second square. The second part, first part, you all can solve it on your own. Please do it as a homework or do it right now and let me know whatever answers you get. Fine. So this is 3 seconds. 3 seconds means from the starting 0 to 3 seconds. So it means S3 is equal to U 0 plus A by 2, 2N. N is 3. No, this is 3 seconds. Here, I am solving this for the third part. N is 3 minus 1. So this becomes 6 minus 1, 5 meters. This is the third part. When we are calculating the second part, we'll use V square minus S is equal to UT plus half AT square. S3 will be in, this is the second part. I have written it opposite. Please just interchange while writing. Be careful. UT 0 plus half A T square, 3 into 3. This is 9 meters. So there's a difference between these two. Write down this. Done, ma'am.
Done, ma'am.
See, this says that a body covers 12 meters in second. Means S2 is 12 meters and N is 2. Then it says distance covered in fourth second is 20 meters. So our N will be 4. So if we frame the equations, first equation will be S2 U plus A by 2 to N minus 1. First equation. Not even S2. We know already our S2. S2 is equal to 12. Similarly, second equation, 20 is equal to U plus A by 2, 2 into 4 minus. These are the two equations you have to solve. First equation, second equation. Fine. Tell me this. See class, this question says that a body starts from rest and accelerates at rate alpha to a maximum velocity v. So this is the case. It is starting from u, accelerating to alpha and reaching up to velocity v. Then it retards with constant acceleration beta, so it is minus beta. Final velocity is this. We have to calculate this velocity. This is the maximum velocity. See the velocity achieved like this, and then it decreased. So this is the case which we have to find it out. Okay, class. It initially increased, then it decreased. So from A to B, let's divide the time into two parts. Let's say this is T1, this is T2. When we are solving it from A to B, we will use V is equal to U plus A T. T is T1. So initial velocity is 0. So this is 0 plus alpha T1. So V is equal to alpha T1. T1 is equal to V by alpha. This is our first equation. Store it. Come to the second equation. From B to C. So this is minus beta, V final, and V. Look, V is equal to U plus A T. This we have to use. Now, what is our final velocity? Final velocity is 0 because the body has stopped moving. Initial velocity is V because we are calculating from B to C. And at the starting point of B, it was V. Acceleration is minus beta, which is the retardation, and time is T2, which we have taken. Now see, 0 is equal to V minus beta T2. So what is T2? T2 is equal to V by beta. This is the second equation. Now what is the total time? Total time is T, which is equal to T1 plus T2. Now we have found the values of T1 and T2. So this is V by alpha plus V by beta. Let's take V common. This is 1 by alpha plus 1 by beta. This is beta plus alpha divided by alpha into beta. This is when we have taken the LCM, right? And this is equal to T. But do we require T? We require V. So V will be equal to alpha beta T divided by alpha plus beta. This is the answer. Write it. This completes with uniformly accelerated motions. Now some other topic we'll do. Write it. See, motion under gravity means when a body freely falls, then gravity assists in the motion, right? Free fall means gravity is helping. You are not providing any force. What is this acceleration due to gravity? It's basically gravity is a gravitational force is a force. We have this chapter 8. So there we'll be studying it in detail. There's a force, gravitational force. All right. So this gravitational force, when acceleration comes into action, acceleration due to gravity, this is g m by r squared. G is a universal constant. This g, it's a universal constant. Means without medium, in any medium, actually, it won't be changing. So it's a universal constant. M is the mass of Earth. There's an entire derivation. I don't want to go into the details right now, otherwise we'll be just studying this, but just for your brief knowledge. And this is radius of the Earth. Now, when you substitute all these values, it's actually the acceleration only, but since it is specifically due to gravitational force, that's why we called it acceleration due to gravity, whose value is actually 9.8 meter per second square. But sometimes roughly for our calculation, we say 10 meter per second square. All right. Now, what all things you have to remember which will be helpful for your exam? For this chapter, firstly, it is independent of mass, shape, and size, and it always acts downwards. Write down till here, then I'll discuss more things. C class. This is clear. Direction of acceleration due to gravity is always downwards. But what about our sign convention? Our sign convention does not just say that it has to be downwards has to be negative or downwards has to be positive. No, sign convention is totally up to you. If I want, I can take upwards positive and I can take downwards as negative. If I want to reverse it, I can make upwards as negative, downwards as positive. But one thing that will remain constant is the acceleration due to gravity. Means the acceleration due to gravity will in any case be acting downwards. So if you are taking the downwards as negative, your acceleration due to gravity will be negative. Okay. And if you're taking it upwards, so your acceleration due to gravity will be positive. Acceleration due to gravity direction will be downwards. If direction of downwards you have taken positive, make it positive. If you've taken it as negative, so then like if this is the case, I have taken upwards as positive and downwards as negative. So my G will be minus 9.8 meter per second square. This is an example, a ball is thrown upwards. Let's say I have taken upwards as negative and I have taken downwards as positive. Fine. So if a ball is going up, initial velocity is acting upwards. Acceleration due to gravity will always act downwards, whether the ball is going up and down. Distance, displacement is also covered in the up direction. So see, displacement will be negative. Initial velocity will be negative. Only acceleration due to gravity will be positive. This is how we take the sign convention. You can take any value, whatever answer you're getting, that will be your final answer. One or two things, note points, which you have to keep in mind before we go on to the questions. See, from the ground, the velocity starts increasing. Initially, it is at rest. Then the velocity increases. And then it starts decreasing. Initially, it is at 0. But then once we have thrown it, from 0, it increases and reaches some initial velocity. That initial velocity decreases and reaches the maximum point in the air, which we call it as the highest achievable point. And that highest point becomes 0. All right. And then the ball comes back to the ground. It achieves the same velocity with which it was thrown. So these things are very important whenever you are calculating numericals, you are calculating the answers. Time of ascent is equal to the time of descent. And at the highest point, you get the 0 velocity. Why? Because the velocity has decreased to 0. That's why the body comes down. If the velocity was not 0, the body will move up only. Since the velocity is decreasing and it becomes 0 at the highest point, the ball stops and starts coming down. If it was not 0, it would have moved upwards. So these are something which you have to remember. Rest of it will be cleared when we'll be doing the questions. Start writing this.